Hi everyone. As Akash mentioned, my name is Chandandeep Singh, and I have been working in computer vision for some time. I've completed my master's in robotic systems. So my specialization is in computer vision for robotics applications primarily. And today, what I'll be talking about is how you can start learning computer vision on your own. What are the tools that you might need? What are the steps that you have to follow? Because starting is always a difficult thing, especially for an advanced field like computer vision, machine learning, or deep learning, and so on. So, first of all, let's talk about what computer vision is. There are a bunch of terms that are being thrown around. Artificial intelligence, machine learning, deep learning. These are just these keywords that are being used everywhere in industry, research, academia, and I'll just quickly try to explain the difference between these terms and how computer vision uh, comes into picture, and how it gets connected to all the other areas that we hear about generally. So the broad category is that of artificial intelligence, and then we have machine learning as a subcategory, and supervised learning, unsupervised learning, and reinforcement learning are the subcategories of machine learning that we know about. And at the same time, artificial intelligence is not just limited to machine learning or using neural networks, but it also has other areas called, let's say, automated reasoning, knowledge representation, and also problem solving approaches. It also has close ties with more mathematical statistics and operations research. And where computer vision actually comes into play is when we are talking about perception of the environment and acting of the environment, especially when acting on an environment also becomes important. Then we talk about robotics, and we are talking when we are talking primarily about perception, then computer vision comes into play. So essentially, computer vision is a subfield of artificial intelligence. Now, how is machine learning connected with computer vision? So computer vision is one area that is dealing with interpretation and understanding of images and videos. And at the same time, we can use machine learning techniques to assist understanding of this process, and I'll talk about how that might work in the coming slides. So there's a really good quote by Fei Fei Li, who says that if we want machines to think, we need to teach them how to see. So this is the whole premise behind computer vision. We want to create systems or machines that can learn to perceive and see the environment. So generally, computer vision actually consists of a lot of different areas. So it's very interdisciplinary. It has, of course, intersections with machine learning, as I mentioned, and it also intersects with computer graphics, image processing, cognitive science, and artificial intelligence, which actually, if you think of the broad picture, artificial intelligence is the broad category, and computer vision is the subcategory. But in this diagram, it represents it in a different way. But the main idea that I want to convey is that there are intersections between machine learning and computer vision. So, why do we need to learn computer vision? So for us humans, when we look at a picture, we can perceive that, okay, this is Abraham Lincoln, and we can get to know different features about this, about the appearance of this person. We also have maybe emotions attached to the image. When we see, we also probably link it to our existing set of knowledge. So when we look at an image, we understand it. um, and this is what we want to enable the machines, the computers, to do as well. But the problem is that the computers don't inherently understand an image just after seeing it, because a computer works in numbers, as we need to see. So what a computer would actually be seeing, it is actually as a collection of pixels of different intensities. Of course, it depends on the resolution here, but essentially what it would be seeing is a set of numbers. Now, to appreciate the complexity of computer vision, you can imagine that if you're just given this set of numbers, now you have to make sense of, let's say, what sort of numbers would represent, let's say, the eyebrows, the hair, the jawline, and other features. So it becomes really complicated to teach the computer to understand uh, several aspects of an image or even a video. And this is what we try to do with computer vision. Now, there are a lot of topics in computer vision actually, and which is also the reason why it is a bit challenging to start learning computer vision. So, one of the key things is basic image processing that is actually a part of computer vision. Some people can say that it's a different field, but there are intersections with it. So regardless of how you view it, basic image processing is essential to start learning computer vision. And what we mean by basic image processing, when we talk about image processing, we talk about filtering images, sharpening these images, these basic Instagram filters, for example. You talk about identification of edges, noise removal, structure extraction, extraction of blobs or circles in images, and so on. So these fall under the category of computer vision. The reason why this is important is because uh, even if you use neural networks, for your computer vision problem, essentially you would have to do some sort of pre-processing to make the images or the data set suitable for the machine learning or the neural network model being used. And then another category is that of object categorization. And here we use, let's say, a sliding window based object detection. We use classification with hog feature descriptors and support vector machines. So these essentially talk about using a conventional machine learning approaches or even conventional computer vision approaches for performing object categorization. So the image that you see here is that of hog descriptors. I'll not go into details of all of these specific approaches, but the point would be that I give an overview of all the approaches and how you can actually start learning. So, another thing you might have heard is that of feature extraction. Now, this is when we talk about feature extraction, we are talking about manual feature extraction using conventional computer vision approaches. Face detection, key point localization, corner detection, Harris corner detectors, local feature extractors like SIFT, SURF, etc., come into play. And then uh, deep learning also assists in computer vision. So nowadays, this is when people talk about computer vision, this is what they talk about actually, but there are a bunch of different aspects of computer vision, as we saw as well. So we see here that classification and localization of objects inside an image, uh, identification and detection of multiple objects inside an image, semantic segmentation, which you see here is we are not separating the individual uh, objects or sheep in this case, but rather have a general sort of segmentation of different types of objects, and then instance segmentation. So all of these things are more complicated tasks, and that is why deep learning assists in these tasks. So this is where convolutional neural networks come into play, and also these are also used for pose estimation. So when you have seen these videos where the pose of a human is visible as well. Semantic segmentation, mask RCNN, fast RCNN, YOLO, all these kinds of models, ResNets, uh, these fall under the category of deep learning. But there are also more advanced topics in computer vision, that of using a stereo camera to actually perform 3D reconstruction. And these use concepts like essential and fundamental matrix, epipolar geometry. Also, camera calibration and triangulation approaches would fall under these categories. And then after that, we can move to talk about motion and talking about how segmentation approaches and 3D reconstruction approaches can be done for videos. So we talk about tracking, template tracking, and other Lucas Canada tracking approaches that are used, and then visual odometry, visual slam, optical flow, video analysis, multi-object tracking, and video segmentation. So all of these seem like a lot of things to learn, right? That is why it's a bit tricky to get started with computer vision. So the idea is that you start with learning basic image processing, and then you learn conventional object categorization approaches, and then you move on to learn feature extraction, and then deep learning, which essentially automates the process of feature extraction. Then you can go on to 3D reconstruction, and then go on to more motion driven approaches. So this summarizes all of the different approaches that are existing in computer vision. Now, the typical university courses, let's say, would follow to a certain extent, more or less, they would follow uh, a structured approach where they would start sequentially from basic image processing and go on to, let's say, motion and video analysis approaches. But my personal experience has been that this is not the best way to learn. First of all, because you would be learning lots of theory in all of these areas, and of course it's very difficult or next to impossible to do projects in all of these areas. So my view is that you first identify what areas you are interested in, and then what you can do is, once you filter out some of your interests, then you can take up a few projects in that particular domain, and take up multiple projects, and then you realize, okay, this is cool, but I don't want to establish a career in this area, and then you can explore more. And this is what we will talk about next. But first, let's talk about what are the applications of computer vision. So these are just general applications that we all know about. Uh, computer vision, face detection, face tracking, object detection. All these things are starting to get embedded in digital cameras and also mobile phones. Mobile phones, and these applications on our phones have computer vision. A lot of these. Uh, Object detection, face identification applications use this technology. And then we have something that is used in more in the medical sector, for identifying diseases using x-ray images and so on. It can also be used for 3D modeling, as we talked about 3D reconstruction. It can also be used in movies, films, and so on. Then there are vision based interfaces, and of course it's used in robotics and autonomous driving as well. So there are a lot of different applications. These are just giving a broad sense of these are just to give you a broad idea of what different applications there are. uh, and the reason why this is important to know the applications is because essentially, in the process that I will be sharing, you have to filter out your interest, and for that you have to know what are the different applications that are existing. And so you can choose, okay, yeah, I'm interested in robotics and I want to learn computer vision for bin picking, or maybe I'm interested in 3D reconstruction and I want to learn more about that. So this is the whole premise of it. Now, let me talk about how I learned computer vision. Of course, I was enrolled at a university program at RWTH Aachen University in robotics, and so I got the chance to learn in-depth theory about computer vision, machine learning, and so on. And I took multiple courses, but at the same time, I took some additional uh, online courses, the ones by Andrew Ng, for example, deeplearning.ai, and so on, which everyone takes, and probably many of you have already taken as well. So there are two aspects of this university and online course way of learning. One is, of course, you get a really good theoretical foundation, but at the same time you have to do lots of activities which may or may not be related to real world case studies, but regardless, you have to get used to using OpenCV, Python and all of these, NumPy, all of these packages basically. So I did a lot of university course assignments as part of my curriculum, and I did online courses and also took theoretical courses in my university. But I would say if I just this part was not uh, simply enough for me to take computer vision skills to the next level or learn even more. So I was fortunate to get some industrial experience. So I worked as a working student in a few companies, and then I did internships and my master's thesis also in similar areas. And this is where I think I learned the most. So one of the very first projects that I did was using machine learning, a unit model for smoke segmentation. And another one that I did was to apply a visual slam for a drone using a real sense camera. And then after that, during my internship, I did use deep learning and object detection and segmentation models to segment objects inside a heap of objects basically, and then the robot would pick it based on the grasp points that are generated from these segments. And then after that, I did some more work in object detection and synthetic dataset generation. So this is how I learned computer vision basically. And by the way, I've also added a link to the courses at my university. The slides and all are available for free actually, so anyone can start learning. And I would say the theoretical slides are really in depth, and they cover the recent research papers. I think they also have slides for all the past years and so on. They regularly update that as well. So if you're interested, you can also check that. Um, but at the same time, I have created a sort of a system or a framework that would help you immediately start learning computer vision after uh, end with this session and go about your day. So I'm a fan of reinforcement learning, and there's this concept called exploration versus exploitation that the reinforcement learning agents go through so as to have an optimal learning rate to achieve the desired outcome. So this is what I try to apply in my own way of learning as well. So the framework that I'm using is that of exploring your interests first. And once you have explored enough and you realize that okay, autonomous driving, let's say, is the area that I'm interested in, and then you take up more and more projects in a progressively increasing difficulty way, such that you can gain mastery in one area. And here I would also like to point that eventually, to get a job, or even to do a PhD or whatever, you have to have one area where you are really good at, and of course having some overall view of all the different areas is also essential. But you have to have a specialization, is what I mean. So let's say you are a total beginner and you want to learn computer vision. How do you start? So the first is selecting a field of your interest. How would you select a field of your interest? At first, you probably don't know which area you're interested in, right? But you see these videos on YouTube, and you attend these seminars, and you talk to people, and so you realize that, oh, okay, let's say robotics is something. Computer vision for drones is something I would be interested in, for example. So what you do is you just choose a project in that domain, and then you learn the necessary theory. And for that, there's plenty of information online. And once you have learned the necessary theory, you can start working on the project. Another optional thing that you can do is you can find an accountability partner. You can talk to your friends, or go on to these Discord servers or Facebook groups or whatever. You can find people who are also starting out, and you can help each other out when you're stuck. And once you finish the project, then is where you have to pause and you have to think, uh, is this an area where I am interested in, where I would like to learn more about? Are you excited by that project or the domain that you chose? And if you did, then what you do is you would take up another project. So another thing to point is that you select a very simple project in the beginning, and once you like it, then you take up another project of a slightly more difficulty. And then if you like it again, then you could eventually be increasing your skill level after every project that you do. And maybe you don't like the thing that you did. Maybe you realize that there's not a lot of opportunities there, or maybe you're just not interested in the project that you did. So you go back to the first step and you explore more. You maybe now you take a different project, maybe in medical image processing or something, and you repeat it the same the same way. So let's take an example. So autonomous driving is something that is growing very rapidly, and we see it everywhere with Tesla and other autonomous driving companies making these announcements about progresses in this area. So you say, okay, I'm interested in autonomous driving, and then you take up a very simplistic project. And of course, for that, how do you know the projects that you have to select? So the idea is to take a very simple project, and I'll talk about how to select projects in the next slide as well. But the idea is to keep the project as simple as possible in the beginning, and not to make it too complex, because if you take up a project that your skill level is not sufficient in, you would lose motivation, because even in simpler projects you might get stuck in the beginning. And let's say you take up lane detection. Now you search online and you realize that you need to learn some theoretical concepts, like it would maybe require basic image processing, like edge detection, hog transform, and these things. So you just learn the bare minimum concepts that you need to learn. And after that, maybe you select an accountability partner. Now, this is an optional step. You can go on to servers like Alphabot Robotics, or the building culture community, or Facebook groups, or you can talk to friends and so on. You can choose an accountability partner as well if you want, and then you start doing the project. Now, I mean, it's really simple to find tutorials on these simple projects. You can find OpenCV tutorials. There are other resources that are also shared online. But the idea is you don't hang up too much on the theory. You start to apply these things immediately. For example, there would be packages for edge detection in OpenCV, and the idea is to start coding immediately. And then if you see, okay, there's a some there I need some more theory, then you go back and watch a few videos as well. So this is my approach overall, how you can start learning computer vision. Now, there are a lot of people who would say that you should take the courses step by step and have a really strong theoretical foundation in all of these areas. Of course, you can do that if you have the time, but this framework that I'm providing is more efficient, because you can start to do hands-on work more immediately. Of course, and also I'm also curious what difficulties you face while learning, um, and what do you think about this framework, if it will be useful or not. So let's now talk about how to select projects. So these are just a bunch of projects that are very commonly used. Of course, cat dog classification and MNIST handwritten digit classification, and face landmark facial landmark detection, automated image captioning, pose estimation, camera calibration, semantic segmentation of objects in bin, cartoonifying yourself, and so on. I mean, the list is endless. But the idea again is to choose the simplest project to start. You can explore GitHub repositories, you can check Medium articles, you can just simply Google it, right? There you will find a bunch of information, but you choose a project and then you stick with it. Another thing that I like to do is to generate ideas myself. So you can generate your own ideas, project ideas. So, for example, you work on your laptop and you think, okay, uh, what if there's an app called app that actually helps you pause your music player without using the keyboard, so you can use your laptop camera to, let's say, do a gesture recognition or something, uh, to build such a system. Now there's already an app like that called Flutter, you probably know about that, but you can come up with your own ideas. And the reason why I encourage you to come up with your own ideas is because you would be excited to do the project and you're more likely to finish it. Otherwise, randomly, if you select, let's say, human pose estimation and you get stuck, or your accuracy is not enough, then you might lose motivation. So this is another thing that you can consider. Of course, you can also Google search your projects. So there are two primary ideas: choosing a very simple project in the beginning, and choosing the project you're most interested in. So choose a project you're interested in that is simple enough as well. uh, Now there's a lot of so it's not just for theory. I've written additional resources. Theory, it's actually some of these resources you can start to use uh, for your projects immediately. So talking about theory, so there's these couple of YouTube channels that you know about. Free Code Camp, it's actually also a very hands-on tutorial based way of learning. They have some tutorials on computer vision and then first principles of computer vision. This is more of a theoretical lecture based learning. And then there's these proper lectures called ancient secrets of computer vision that you can check. uh, of course, there's this Professor Cyril Staknis from University of Bonn. You can find his lectures as well online. I used to refer them. They're very detailed. So especially if you want to go into research, these lectures would be helpful. But if you want to just get started with doing projects, I think for me personally, I found this PyImage search as the best resource, where you can start to use OpenCV, computer vision, and deep learning, because they have very structured step by step guidelines on how to start doing a project. Even they even have tutorials on installation of OpenCV and its dependencies, because initially that could also be a problem. And another one is Augmented Startups. This is another good website. They have a YouTube channel as well, and they teach how to build projects, how to use different models, YOLO, Mask RCNN, and so on. So, and of course, you can go directly with OpenCV tutorials. It's very detailed and very hands-on. So these are some additional resources that you can refer to. But again, my view would be to take a project of your choice and progressively increase your skill level and the difficulty of the project. And these are some of the references that I used in making this presentation.